So I started off solving this problem and I was cut off in the previous video, but I could not continue on. So I am going to continue on. I am proving that this quadrilateral with the vertices A, B, C, D is a rhombus. And first I have to prove that it is a parallelogram. And I decided to start off by using method 1 again, even though I probably should have tried something different, but I was rushing because I was rushed for time. So I'm going to continue on using the midpoint to show that the midpoints are the same from A to C and B to D. So I would get 5 over 2 from A to C and 9 over 2. I can leave it like that. And I'm just going to show B and D are, in fact, the same midpoints as well. And so for my x values, I have 2 plus 3 divided by 2. And for my y values, I have 6 plus 3 divided by 2. And looks like I am going to, in fact, get the same. I get 5 over 2 and 9 over 2. So they have the same exact midpoint at 5 over 2 and 9 over 2. So it's a parallelogram. So now I can go on and prove that it's a rhombus. And let's go back for rhombus. And it said that we can prove the diagonals are perpendicular. I can prove that a pair of adjacent sides are equal, or I can prove that all 4 sides are equal. I think I'm going to show that the diagonals are perpendicular to each other instead, because I'm already pretty much there, because I've already started off looking at the diagonals, so we might as well continue on. So first, let me clear, because I can't keep going because I was running out of space. So let's look at my diagonals and see if they are perpendicular to each other. So that means I need to find the slope of AC and BD, because those are my diagonals. Let me see if those two things are perpendicular. So AC, we'll say that A is my 0.1 and C is my 0.2. It doesn't matter which one I make. And I'm going to have to use M again for slope. And I apologize because I use M for midpoint. I'm going to have to find another way to use for midpoint, because M is definitely reserved for slope. So I have my y2, which is 6, minus my y1, which is 3, divided by my x2, which is 7, minus my x2, which is -2, so this is negative minus. Minus negative, which changed to a positive, plus. So I get 3 over 9. Now let's do BD. So my slope for BD. So I'll make this my 0.1 and this my 0.2. So that would be y2, which is 3, minus y1, which is 6, over x2, which is 3, minus x1, which is 2. And I get -3 over 1. And that would look like it's not, but I forgot to reduce up here, and I wish I was in the classroom, because if I was in the classroom, someone would have said, hey, Dr. Kate, you forgot to reduce. Always reduce. Please always reduce. This reduces to 1/3 and 1/3, and -3 over 1 are in fact negative reciprocals of each other, so they are perpendicular. So this is a parallelogram and a rhombus. All right, let's do another one since we went back and we have more time now. Let's see if this is a square. So we have 0, 0 for A, 4, 3 for B, 7, -1 for C, and 3, -4 for D. And it could just be me, but well, it's probably just me. My drawing is probably off. It does not look like a square as it is right now. Let's go back to see what we have to prove for a square, because we don't have to have this memorized. We can write it down somewhere. So it tells us here that we need to do these three things. We need to prove that the diagonals bisect. We need to prove that they're equal and they're perpendicular. Okay, so we're all looking at the diagonals. This is just one way of doing it. There are multiple, many ways to do this, but we are going to do this. So we're gonna just look at the diagonals. And the first thing that I'm going to do is to see if they bisect, and that means that they have the same midpoint. And I know we keep doing the same thing over and over again. I apologize for that. I didn't mean for it to go this way. So let's see. Midpoint. What can I use for midpoint? So I use H for midpoint. So the halfway point between A and C, it would be x1, so 0, plus x2, which is 7, so A and C divided by 2, and y1 plus y2 divided by 2, and that gives me 7 over 2, and negative 1/2. Let's see if it is the same for BD. So we have 4 plus 3 divided by 2, x1 plus x2 divided by 2, and we have 3 plus negative 4 divided by 2, y1 plus y2, and we get 7 over 2, and again negative 1/2. So the diagonals bisect. Let's see if they're equal to each other. We can find the distance. So looking at from A to C, we have 7x2 minus x1 squared plus y2 minus y1 squared, and that's going to give me the square root of 7 squared plus negative 1 squared, which gives me, and I should have said AC so that I can distinguish, the square root of 49 plus 1, which is equal to the square root of 50. Let's see if BD is equal. X2, which is 3, minus x1, which is 4, squared, plus y2, which is negative 4, minus y1, which is 3, squared, gives me 3 minus 4 is negative 1, squared, plus negative 4 minus 3 is negative 7, and that does in fact, we just have it up here, 1 squared plus 49 plus 1 squared plus 7 squared is square root of 50. So the diagonals are equal. Now we need to show that those diagonals are perpendicular. So we're going to find the slope now, and that's when I'm going to use M. So the slope of AC is y2, we'll say c is 2. So first point, second point, first point, second point, so on and so forth. So we have negative 1 minus 0, y2 minus y1 over x2 minus x1 gives me negative 1 over 7. Then we'll find the slope of BD. So my D is my second point, so that's going to give me y2, which is negative 4, minus 4. Uh-oh, I hope it works out. No, this is supposed to be, again, I wish I had someone here to shout at me when I make mistakes. So negative 4 minus 3, that's the y value. And then 3 minus 4. Yeah, those 3 and 4s can confuse you, or well, they confuse me anyway. So I get negative 7 over negative 1, which is just plain old positive 7. And so these two are definitely negative reciprocals of each other. So everything works out. It is a square. So it was just me. It was my drawing. I don't believe we have time for any more, so I'm going to stop right here. And if you have any additional questions, please feel free to ask.